Hello, I'm Jason Chatham. Welcome to Wits Software Development 2016, supported by Math Sciences Support Group. Today we'll be covering development strategies and some programming architectures. Development strategies are general strategies for developing software. These are specific rules which govern the way the different stakeholders in the project need to operate in order to develop a piece of well-constructed software. Today we'll cover several different models of development. We'll start with the software development lifecycle, which is a general catch-all model, specifically for the more classical ideas of software development, but also some of the more modern agile approaches. Since the software development lifecycle is considered the classical approach, it is very rigid, and it's usually used when talking about monolithic and uniform software packages, sort of the old idea of what software is. Under the software development lifecycle, there are several classical models. We'll be covering three of those: the waterfall model, the spiral model, and the prototyping model. These models tend to have distinct phases of development, which have very rigid borders between the phases, so you don't have design and implementation together, etc. The waterfall model is considered the most classical model. It's the one most people know about. Here, there are very distinct phases that fall into each other, and backtracking isn't encouraged. So you can go from figuring out what the requirements of your software is to designing the software, but you shouldn't then go back to add more requirements. It's possible, but it's discouraged. The waterfall model does have some advantages. Testing is enforced at every phase of development, and there's documentation for every phase of development. However, it's very costly, it's not very client-friendly, and it doesn't handle change very well. Software is all about change and changing the requirements of the client. The waterfall model does not map well to that sort of change. The circular model tries to address client involvement. Here, various parts of the system are developed within their own subphases, which can be delivered to the client. The problem is it has to be planned very methodically, and estimation of software has to be done precisely. There will be more realistic estimates as you're planning at a more granular level. Change is handled better, but it is very costly and can take longer, and small projects don't really fit well into this model. The prototyping model attempts to bridge the circular model and the waterfall model. It attempts to create essentially smaller circular models within each phase of the waterfall model. So the modern approach to the software development lifecycle is the agile approach. It is sort of the catch-all of the modern design methodologies. These include evolving solutions and collaboration between cross-functional teams. It also focuses on client involvement in the project and smaller release cycles in order to produce the parts of the product rather than the whole product at the end, as that's been found to fail and people not being able to actually deliver anything. The agile approach has 12 principles, but the main point of the agile development model is that there's a focus on simplicity and on the client, as well as changing functional requirements. So this model is quite adaptive and is able to deliver small chunks of a product rather than the whole thing in one go. Scrum is the first submodel of the agile approach. It emphasizes feedback continuously throughout the development. There is a product backlog, which is all the requirements that the team has to produce. There is the sprint backlog, which is the backlog for the specific sub-unit of work, the requirements that they need to get done at that point. And then there's the actual sprint, which is itself broken down into two parts. This diagram shows 30 days for the whole sprint and 24 hours for sub-functional units. However, the time can be different depending on the team and the specific implementation of Scrum, And then at the end of each sprint, you have some working increment of software, which you can then deliver and move on. At that point, the client can give feedback and new functional requirements can be added to the backlog, and this process iterates over and over until the client is happy and the product is complete. Scrum is the simplest agile approach. It is very iterative. There are only 3 member roles, so there's the product owner, the Scrum Master who's in charge of ensuring that Scrum is adhered to within the project, and then a Scrum member, which are just the programmers, business analysts, and interface designers of the project. It recognizes that the customer can change their mind midway through the development cycle, and it accepts that the project cannot be fully understood or defined. Extreme programming is another model under the Agile umbrella. Windows XP was Microsoft's experiment into extreme programming. It requires immense discipline and very rigid planning. It can be very daunting, and it has tended to fall away with the deadlines of internet deployment of software because of how much work is required to use the extreme programming model. This model focuses on rapid development of a lot of features within a very short period of time. The idea is to improve productivity of teams rather than improve deliverability of software. What has evolved from this, which is still used quite often today, is paired programming. So paired programming is where pairs of programmers team up to program the same functional requirement. One is the driver who actually writes the code, and the other is the observer who observes the driver writing the code and makes suggestions, states the functional requirements, and makes sure that the software being produced is of high quality. Classically, the 2 switch roles frequently, and whilst the observer focuses on the strategic direction of work, the driver focuses on the specific code. This helps with morale, and it can also help train younger, less experienced programmers in a team. Test-driven development is the final agile model we'll be discussing today. The focus of test-driven development is to ensure that the programmer or the team of programmers stays within the boundaries of the defined system, so not adding any more features that are not required for a product to be developed. The idea is to produce the minimal viable product without adding extra requirements, extra code, or extra features, which might slow the system down, might bog down the development team, or might introduce bugs. Most test-driven development occurs with automated tests, which are written by software developers before they start programming the final product. The idea is that you always have a test for any of the code that you develop. That way, no bugs or extra features can find themselves in the system, as there are tests for every bit of code, and the tests are written based on the business rules and the functional requirements of the system. There are downsides to this approach. It may slow down development. It may also be too strict, as you are doubling the work of the team. And also, it may not adapt quickly enough to a changing environment if the system is, or the product is, relatively new in concept. We'll now be talking about some system models. These are models for designing software systems. These are overarching architectures which are used to help developers make systems which have specific properties and which are able to be tested more easily. We'll only be covering 3 of these models today: the layered software model, the event-driven model, and the modular model. Application interfaces are the interfaces between any applications or parts of applications, modules. The internet works in this way, but any kind of program system that has a communication interface is essentially using an application interface. So here you can see in the diagram that there are 2 systems or 2 modules that are communicating with each other. The layer in between these systems, the space where the arrows occur, is the application interface. This allows for black box design, so as long as you know what that interface requires to get input or to get output, then you know how to interface with that other system or module, and you don't need to understand how that module works from the point of view of the module you're programming. The layered software model, it expands on this application interface idea by having several layers which help break up the code into different responsibilities. So you have the data access layer, which is the layer that contains the file, input, output, the databases, and any kind of data access. The business layer, which is the layer responsible for business logic and enforcing that logic, ensuring that certain rules are enforced and other rules are not enforced as needed, such as user roles, admin versus non-admin. The application layer is where the main application lives. This is sort of the layer that ties everything together. And on top of that is the presentation layer. This is where inputs are validated and the user experience is programmed. These layers are very much bounded, so it's considered very bad to break between layers. So every layer must only be able to communicate with the layers directly above or directly below it. You shouldn't communicate over layers. Layers can also have stubs or subsystems that it communicates to on the side, such as a web interface, a web database, or something like that. Using the example from last week, I have modified it to become a layered system model. Okay, here's the code from last week. You can see there's lots of different functions, but they're all in one file. What I've done is I've broken up the files into assumed layers. So the index would be the application layer, and here you can see it calls on something called the logic layer, the data layer, and the presentation layer. And when you go to them, you can see that these layers are only responsible for very specific tasks. So the data layer is responsible for handling the data of this game world. And then you can see at the bottom, there's this module.export, which allows you to take a JavaScript file in Node.js and import it using the require statement here in index.js. This is not a proper layered model architecture because index is communicating with all the layers rather than communicating between layers. So you are jumping over layers here. The fourth example remedies this, as you can see, by making index only communicate with the logic layer, or application logic, business logic, and the presentation layer. And if you go to the logic layer, you see it communicates with the data layer, and now everything flows in the correct manner. This would allow for much more easy testing of these layers, as they're not interdependent, so you don't have to test between layers. You just test each layer. You just make sure that the correct actions are occurring within each layer. The next model we will talk about is the model view controller. Here, the software is broken up into three parts: the model, the view, and the controller. The model are classes or objects which represent the data being used in the system. The view represents the view of that model to the customer or the user. So the view handles actually rendering that information, validating that information, and the input and output of that information. The controller handles the logic that connects the models to the views. So it handles any rules governing the data. It also handles how the data is stored and interfaces with other parts of the system. All these system models can actually be used together. They're not, you don't just use one of the model. You tend to find software makes use of many of the models. So model view controller is used within the layered software architecture or in some other architecture as well. An example of the model view controller would be Express.js. I have an example node system website, and here it makes use of the model view controller or something very similar by having routes which could be associated with controllers, which deals with how data is handled. So for instance, how do you log into a system, or making sure something is an admin or not an admin. Then you also have views, which again are the views, and this shows how that data is rendered. And then you have models, which are the models of the system. So the models in Express.js aren't created alone. You've actually got to create them because you've got to choose what sort of database system or file system that you want to use. However, it doesn't matter what you call it. This is sort of the model, an underlying design decisions of Express.js. Event-driven model is the last model we'll be looking at. This model relates very closely to how Node.js itself works. So Node.js waits for a request and then does some kind of processing on that request. So the same thing can occur with the event model. The system waits in some kind of loop for an event. It can be a system event, a user event, user action, or anything else that could occur. Once that event happens, checks that command queue for some command that will correspond to the event. There's usually a catch-all error or a catch-all event if it doesn't have a command specific to what has occurred. Express.js and Node.js kind of use a hybrid model between event-driven model view controller and even modules. So Node.js prefers modules, which we'll discuss in a moment, but Express.js makes use of model view controller and the event-driven model. When you use Express.js and there is no user on the system is essentially halted, nothing is occurring. But when the user logs in or clicks a button or loads a web page, then it begins to run through the system and the controllers. So in that sense, it is also event-driven. The event-driven model, shown on the state diagram, is essentially 3 states. So some request comes in and it's in the ready state, so nothing is occurring. And then it'll dispatch it into the running state. And then if something goes wrong, it'll time out, go back to the ready state and throw an error, or it'll block the system whilst it's interfacing with input and output. And then when that is complete, it'll go back to ready state. And eventually the system can terminate through the running state. So if the system manager switches off the website or something like that, because this model tends to not exit by itself. That's considered a bad way of programming it, as a termination state can never be reversed. So you would have to manually go in and restart the system. Modular development is the final model we'll be discussing. So here code is broken up into smaller modules which can be reused. The idea is to reuse this code. So rather than reprogramming, authenticating the user, you have one module that does that, and then you reference that module in other code. You can also have independent development teams that build different modules. Node.js is constructed to be modular. So if we look at the final tic-tac-toe code for this session, you can see that we are using libraries. Those would be considered modules. And the way you create these libraries is by using the tool npm, but the actual code is very similar to how I made the layered architecture. So you import something like the logic layer here, but in the logic layer, the only part of code that you need is this module.exports. This statement and object describes what functions are public, so what functions any other module of code can see when you're using this required statement. The functions that aren't defined in module.exports cannot be accessed outside of that module. The idea is that you then have some kind of concept of public and private within Node.js, so that you can control what other modules can access. You use some functions you don't want other modules to access. I will now be covering a short demo on how to use Express.js. So Express.js does come with a generator that will generate a code boilerplate. Or a general template that you can then use that will help you to apply the Express.js library to whatever you are trying to do. The first thing you need to do is in your terminal, preferably a bash terminal, is type in npm install -g express. I've already done this. Once you do that, you can type in express-e in a blank folder. Don't try this in a folder that contains stuff. I'm in a blank folder. Here I'm going to type in express-e, and you can see it has generated a template for me to use. So Express by default uses a library called Jade for the views to actually help generate the views dynamically. It's a lot more difficult to use Jade, so the -e tells it to use Express.js, which is a different library that is closer to HTML. So if we go to this blank directory, you can see that it has generated a whole bunch of folders and files. There's a file called app.js. This is the main application logic. This is where most of your programming or connecting modules will occur. As you can see, it is a module, so it doesn't run by itself. It actually runs in this bin folder, www. This is where the website server is set up, and as you can see, it imports the app. It sets up settings such as the port of the site, and then it actually runs the server. And this is the event model here, where it is actually listening for errors and listening for events to occur that are based on that app file. So if you go to the app file, you can see that this is where the error pages will be rendered, and you can see that it is actually got the statement called app.use, and in here it is waiting for someone to actually connect to the main site and then connect to a user's subpage, and then it will render those pages, else it will show a 404 error. Or if it isn't a not found error, it'll show a default error 500. So now we have this blank project that we can start using. Some tutorials I'd suggest you go through would be Node School. These other two are also very good to go through. However, Node School, there's many different tutorials, and the ones I would suggest would be some of the core tutorials, depending on your skill level. So JavaScript, Learning Node, NPM, Git maybe, and some others that you might fancy doing. So you need to have some kind of Node terminal. So in Windows, when you install Node, it has a command line, and in Linux you can just use bash. Also in Windows, if you've installed Git and Node, you can use the git bash terminal to work with Node. Some electives you should probably do as well is ExpressWorks to learn the basics of the Express framework, and the MongoDB tutorial, which is called Learn New Mongo. For this course, there will be a project that you are expected to do. So in these sessions, we are developing this tic-tac-toe game, but alongside that, you should also be developing this other project, which will only have code presented to you the next session after you've done the code. So what we'd want to build is a simple web interface which allows you to input a folder on the local computer and scan that folder for any media, any kind of file really, and then store that information, that metadata, in a database. And then there'll be another part of that website. A simple single page or double page is sufficient, but in that second part of the website, you can then search for stored information and pull it out from the database. By searching, it can just take all the information from the database and present that on a web page. You don't have to become fancy and put anything complex. For this week, all you need to do is use the library readline-sync, which I've used with the tic-tac-toe game to get a specific folder name, and then display that information using console.log, which is a simple statement that displays text to the console. Just a quick example. So in this Express.js that we've made, before you run it, you need to run npm install by itself to install all the different files before you can actually run it, which would be node node bin www to actually run the program. I haven't installed the module, so you'll get this error where it'll say can't find module, and then you need to type in npm install to get it to work. To install readline sync, you need to type in npm install -- save readline -sync to actually install that library in order to use it, and then type in npm install to install it and all the Express.js dependencies. Here are some links to use readline sync, such as its product page, and there's also a Stack Overflow which talks about how to use it. In the next session, we'll cover how to build tests and how to use database, as well as some code patterns. and I again discuss what tutorials you should be doing on nodeschool.io. Okay, thank you and goodbye.